Okay, today we're going to talk about relations, domain, range, function notation. A relation is an element where one set is associated with an element in another set. In other words, it's a set of points. The domain are all the x values. They're called the input. They're the independent variable. And the range is the y values in a relation. They're the output or the dependent variable. I have a relation here of the point 0, 1, 5, 2, 6, 4. Out of this, the domain would be 0, 5, and 6, due to the fact that the x's are 0, 5, and 6. And the range would be 1, 2, and 4, because the y's are 1, 2, and 4. Now, sometimes when you get a picture, it's easier if you write out what it shows you. So I find out that domain is R, H, O, and Q, and my range is 2, 4, and 5. Notice they did place them in numerical order. Okay, so my domain across here, domain is left to right because it's across the x, so my domain is -2. Okay, we're split at 1, 2, 3, 4, 5, so this is -3/5. 1, 2, 3, +3/5. 1, 2, and 3. It's my domain. My range, we do bottom to top. So my bottom is, I'm going to go with -3. These are all at 0. 2, 8, 4, 8, 8. 4, 6, 8. So my domain is -2, -3/5, 3/5, 1, 2, and 3, and my range is -3, 0, 2, and 8. And even though I had 3 zeros, I only wrote them once. Okay, now a function is a relation in which the domain, the input, has only one range value, the output, which means it can pass the vertical line test. So if we have a graph and we want to see if it's a function or not, you pass a vertical line down any part of the graph. If I pass a vertical line down and it touches more than once, which this does, here and here, it is not a function because it fails the vertical line test, meaning that the domain repeats. If I pass a line down each of these, they only touch once, so it passes the vertical line test, so it is a function. Place a line down, touches once, once, it is a function, it passes the vertical line test. Pass a vertical line down, touches twice, touches twice, touches twice. It's not a function, it does not pass the vertical line test. It only has to touch something twice, one time, to not be a function. Now, just to keep my eyes not goofing them around, I'm going to do -3, 3, -2, -6, -1, 0, 0, 15, 1, -1. Now, I don't want to have to graph all the time. Okay, so I'm not going to graph these. What I'm going to do is look at the x values, because that is my domain. And if the x values repeat, it's not a function. My x values do not repeat, so this is a function. It's a function. Domain does not repeat. Okay, I'm going to do this next one. -3, -6, -2, -1, -1, 0. 0, 3, 1, 15, and 1, 0. You'll see I have 2 1s. So this is not a function because the domain repeats. It's the same thing as graphing. I'm looking to see if the x's repeat, but I don't want to graph each time. So if my numbers are listed out, I'm just looking to see if the x's repeat. Remember, the x's name is domain. Okay, to determine if an equation is a function, solve the equation for y and see if one x corresponds with one y. So this is a function. 1 is graphed as a line. Okay, anything linear is going to be a function except for a vertical line. The reason for it is a vertical line will always touch. So a vertical line is not a function, but this is a function because 1x goes with 1y. This is the form of a parabola. A parabola is a function because every time I put in an x, I'm going to get a different y. Or I might get the same y, like 1 squared and -1 squared, but they're two different x's. This is not a function because this is a sleeping parabola, and sleeping parabolas are on their side, and as you can see, they touch more than one time. Therefore, it is not a function. Okay? Because The square root of 4 can be 2 or negative 2. So 2, 2, 2, negative 2, domain repeated. To find the value of a function, and you can use what's called function notation. Function notation is, instead of calling everything y, we give it a letter like f or h or g, so that we can tell you which equation to go to. This is equation f of x. It means the same thing as y equals x squared plus 6x. This means take out x and put in 3. So take out x and put in 3. Now x is at 2 spots, so I have to take it out at 2 spots. So 9 plus 18, 27. This says take out x and put in negative 2. Now remember, when you have an exponent, to use parentheses, because if you do not, you're going to get it incorrect. So when you're placing a negative number in with an exponent, especially if that exponent is even, you should put in parentheses. Negative 2 squared is 4. 6 times negative 2 is negative 12. My answer is negative 8. In this case, this is f of z, means that z is my variable. I am supposed to take z plus 3 and plug it in for everywhere I see z. 4 times z plus 3 plus 7. 4z plus 12 plus 7. 4z plus 19. Now the next one is a two-step problem. It wants me to take z and plug it in here, which it already is, 4z plus 7. Plus, it wants me to take 3 and plug it in here, 4 times 3 plus 7. So it wants me to do it two different ways. One by plugging z in, which is the same thing, and one by plugging 3 in, and then add the two together. So 4z plus 7 plus 12 plus 7. 4z, used to making x's, 4z plus 26. Okay, I have an f of x that's 3x plus 2, and I have a g of x, which is negative 2x squared plus x minus 3. Let's say I want f of 4. This says go to the f function and place in 4. So 12 plus 2 is 14. Let's say I want g of 4. That means go to the g function and place in 4. Now notice I'm putting it in all the x's. So 16 times negative 2 is negative 32 plus 4 minus 3. Negative 31. Now don't fall for the fact that it's always the one above it, because here I have f of 1, and I need to go the whole way back here and put in 1. So 3 plus 2 is 5. Always look at what letter you're supposed to be going to. This is a compound. I got to do two different things. First of all, you can see it written like this, or sometimes it'll look like almost like the word fog, and this will look like golf. So if you see it either way, that's what it means. It wants you to take 2 and put it into g. So I'm going to take negative 2 times 2 squared plus 2 minus 3. 4, negative 8 plus 2 minus 3. Negative 11 plus 2, negative 9. Then they want you to cross this out and put negative 9 and take negative 9 and put it into f. So we're taking the number, putting it into the middle one, and then taking that one and putting it into the last one. So 3 times negative 9 plus 2, negative 27 plus 2, negative 25. My total answer is negative 25. So it's a two-step problem. So going the other way, I'm going to take 2 and put it into f. 3 times 2 plus 2. 6 plus 2 is 8. Cross this out and put in 8. Now I'm going to take 8 and put it into g. Negative 2 times 8 squared plus 8 minus 3. 64 times 2 is negative 128 plus 8 minus 3. Negative 123. So my total answer is negative 123. So it's taking one, putting in a number, taking that answer and putting it in the other one. So that's function notation with compound function notation. Okay, functions and their graphs. Domain is the largest set of real numbers that makes f of x a real number, and it goes left to right. Domain is normally negative infinity to infinity, meaning all real numbers, unless two things occur. One, you have a denominator with a variable in it, and if you do, you had to take that denominator, set it equal to 0, and that becomes a restriction. So your domain will jump that spot. If you have a square root, you have to take the number under the square root, which is called the radicand, and set it greater than or equal to 0, because remember, a square root cannot be less than or equal to 0. And then that becomes the beginning point or the end point of your domain. But the first thing you do is look to see if you have a denominator or a square root. G of x does not have a denominator or a square root, so its domain is negative infinity to infinity. G of z has a denominator, so I take the denominator, set it equal to 0. Z cannot be negative 1, which means that it runs from negative infinity to negative 1, jumps negative 1, and goes to infinity. It's not allowed to touch negative 1. What's actually happening there is you have an asymptote, and that asymptote is an imaginary line that the graph gets closer to but never touches. That's why it's jumping over it. H of x has a square root. If you have a square root, you take the radicand, which is the number under it, you make it greater than 0. So x has to be greater than 2, which means that it starts at 2 and goes to infinity for its domain. So now remember, domain is always negative infinity to infinity unless you have a denominator with a variable in. If you do, you set that denominator equal to 0, and it tells you where your asymptotes are, where you jump, where your domain is split. If you have a square root, you take your radicand, which is the part underneath the square root, set it greater than 0, greater than or equal to 0. I'm sorry, I should put equal to there. And then it starts there and goes to infinity, or it starts at negative infinity and goes to that number, depending on which way it's facing. Okay, find the domain. Let's go back to the rules I just told you. Does it have a denominator? No. Does it have a square root? No. Then the domain is negative infinity to infinity. Okay, now what if we have a graph? How do we determine domain that way? Well, domain is left to right. So go to the left and I hit an arrow. That means it goes to negative infinity. Go to the right, I hit another arrow. There's nothing skipped in the middle. So apparently my domain is negative infinity to infinity. To do your range, range is bottom to top. So at the bottom I hit arrows. So that's a negative infinity. At the top I hit 1, 2, 3, 4. And it touches 4. So it's a bracket. Parentheses, does not touch, is not included. It's like an open dot. Bracket, touches, included. That's why I used the bracket on the 4. Okay, my x-intercepts I'm going to estimate because I can't tell from here exactly. So I'm going to say my x-intercepts are negative 1/2, 0, and 1/2, 0. And my y, that's here, and my y-intercept is 0, 4. Okay, let's put arrows on the end here. Domain, left, negative infinity, right, positive infinity, nothing skipped in the middle. Range, bottom, top, negative infinity to positive infinity. X-intercepts, 1, 2, 3. Negative 3, 0. 1, 2, 3. Positive 3, 0. Y-intercept. Oh, and an x-intercept 0, 0 because it touches 3 spots. 1, 2, 3. And the y-intercept is also 0, 0 because that's where it touches the y. X-intercepts are called zeros of your functions. So when we start talking about zeros, well, we're actually looking for our x-intercepts when we get there. Okay, I have a graph and I want to know if 3, -1 is on the graph. This is x, this is y. This is y, this is x. So I plug in the 3, and I plug in the -1. I get -1 equals 6 minus 5. So -1 equals 1. So no, it's not on the graph. Then the next question says, what if x is 1? What is y? Y is equal to 2 times 1 minus 5. Y is equal to 2 minus 5. Y is equal to -3. That would be a -3. What if f of x is 3? Well, f of x is the same thing as y. So it's saying, what if y is 3? So 3 equals 2x minus 5. Move my 5. 2x equals 8. Divide by 2, x is 4. The answer is 4. I need you to get used to the fact that f of x is the same thing as y. So if you have to substitute in or need to think about it in a way, think about it as y. Okay, so what are the zeros of the function? A minute ago I told you that the x-intercepts are the zeros of the function. So I'm asking for the x-intercepts. So the x-intercepts are -3, 0, and 2, 0. So I want you to understand that the x-intercepts and the zeros of a function are the same thing. Now, here are a lot of different graphs. These are called parent graphs, meaning that they're the basic graph for this function. This is a constant, which is a horizontal line, which y equals b. This is the linear equation, which y equals mx plus b. This is your quadratic, which is y equals x squared. Here's your cubic, which is an S graph, which is y equals x cubed. Here's your square root function of only the primary roots, y equals the square root of x. This is your cubic function, which is your cubic root function, which is y equals the third root of x. And notice they all say f of x, I said y, it's the same thing. This is your parabola, your hyperbola. This hyperbola occurs when you have a split in your domain, like when we had a restriction on the last one where it couldn't be 2 or -2. That's where the split comes at. There's an asymptote going up this axis and this axis on this one. It's in y equals 1 over x. Absolute value looks like a v. Y equals the absolute value. The exponential function, y equals a times b to the x. The identity function is y equals x. And the log function is y equals log of x. Through this whole course, we're going to be talking about almost all of these parent graphs. So you can always turn back and look at these parent graphs from this page. Now, right now we're going to concentrate on linear functions. A linear function is in the form of y equals mx plus b, where m is your slope, y is, the b is your y-intercept. Slope is also considered your rise over run, and the y-intercept is always also considered your starting point. So if I wanted to graph in linear function, I start at my starting point, which is my y-intercept of 2, and I put a dot at 2. Then I come over and I rise 3 and run 4. Rise 3 from that dot and run 4. Graphed. Very easy to graph in y equals mx plus b form. It's actually considered the graphing form. Okay. This is not in the graphing form, so we have two choices. We can change it to y equals mx plus b, or we can graph it using what are called the x and the y intercepts. So here I'm going to put x0 in for x, so x disappears. I get -4y equals 8. Divide by -4, y is -2. So this is my y-intercept. Then I'm going to go back. This is x and y, and I'm going to put 0 in for y, so my y disappears. So I get 2x equals 8, divide by 2, x is 4. This is my x-intercept. So I can do a really quick graph going to -2 and putting a dot on the y, and 4 on the x, and graphing it. Okay? It's always better to probably graph in y equals mx plus b form, but sometimes just graphing with the x and the y intercepts makes it so much easier. Okay, I want to find the zeros. Zeros would be my x-intercepts. So to find the zero of a graph, set f of x or y equal to 0. So I'm going to send 0 equals negative 4x plus 12. I'm going to move my 12. Negative 12 equals negative 4x. Divide by negative 4. X is 3. So my 0 occurs at 3, 0. When they're asking me for my zeros or my x-intercepts, remember zeros and x-intercepts go together. They're interchangeable. What they're asking you to do is to plug 0 in for y. Okay, some problems. Tony's weekly salary is 0.75% of his weekly sales plus $450. The linear equation is f of x equals 0.0075x plus 450. The reason I got 0.0075 is a percentage changed to a decimal moves the decimal 2 spaces over, giving me 2 zeros. Now, what is a domain? According to what I told you earlier, there is no denominator and there is no square root, so it should be negative infinity to infinity. But in real life, it's not always that way. If you look, his salary starts at 450. It's not going the whole way to negative infinity. So his salary will start at 450 and will go to infinity. Even though I told you previously it's like that, you have to think in real life, can that really happen? If Tony sells $50,000 in 1 week, what is his salary? So his salary is f of x. So I'm putting f of x equals 0.0075 times 50,000 plus 450 to find out how much his salary would be. So 0.0075 times 50,000 plus 450. His salary would be $825. If Tony earns $600 in a week, how much did he sell? Well, in this case, I know his salary is $600 and his salary is f of x. So it's 600 equals 0.0075x plus 450. So I move the 450. 150 equals 0.0075x divided by 0.0075. So 150 divided by 0.0075 gives me 20,000. So he must have sold $20,000 in sales. So it's just where you're putting it in at. So you have to understand what f of x is just y, and whatever y's value is, that's where you would plug that in. And x, of course, is your x. If Tony, suppose a bike manufacturer has a daily fixed cost of $2,000 and each bike costs $80. Write an equation. Well, you have a fixed cost of $2,000, so that's your starting point. And then it's $80 per bike. We don't know how many bikes, so f of x equals 80x plus 2,000. What is the daily cost of 5 bikes? Well, the cost is f of x, so 80 times 5 plus 2,000. F of x is equal to 400 plus 2,000, which is $2,400. How many bikes can be produced for $2,800? Well, this is the f of x, or the y. So it's 2,800 equals 80x plus 2,000. Move your 2,000. 800 equals 80x. Divide by 80. X is 10 bikes. So it's all in how we're moving around using our functions to find either if we're putting something in or what we want to get out, the input or the output. Now it's your turn.